Hello everyone, this is Prestige Academy's online lessons. This is Algebra 1, Class 7. Today we'll be going over solving quadratic equations, quadratic formula, and graphing quadratic functions. Let's start with solving quadratic equations. Now in the last class we learned about factoring. We had something like this and we separated that into two parentheses. And we did that by first finding the multiples of the C. This was B, this was A. The multiples of 2 are 2 and 1. 2 times 1 is equal to 2. 2 plus 1 is equal to 3. So we know the numbers are x plus 2 and x plus 1. And that's how you factored quadraticals. Now, what if we have something like this? The numbers are equal to something. Now, we first want to, when we're solving quadratic equations, we want to move everything to the side. So in order to do that, we would do plus 4 on each side and rewrite everything like 3x squared plus 7x plus 4, because of this plus 4, equal to negative 4 and plus 4 are going to cancel out, 0. Now after we got this form, we need to solve for x, which means we want to get something like x is equal to something. In order to do that, we first factor whatever the statement is. Now the rules for when a wasn't equal to 1 were if we multiplied 4 and 3, that's going to give us 12. And then found the multiples of 12 that are going to add up to 7. And the multiples of 12 are 1 times 12, 2 times 6, and 4 times 3. 1 plus 12 is 13, so it's not equal to 7. 6 plus 2 is 8, so it's not 7. 4 plus 3 is 7. So we're using 4 and 3. And when we got that number, the way we did this in the previous class was we wrote the first term as this, and then separated the second term into these two, 4x and 3x. And as you can see, when you do 4x plus 3x, you still get 7x. So you're not changing this number, you're just separating it into 2. Then let's carry the plus 4 down, equals 0. And then we group this. Let's group 3x and 3x squared together and 4x and 4 together. Well, we can take out of 3x squared, and 3x is 3x. 3x squared divided by 3x is just going to leave us x, plus 3x divided by 3x is just 1. So that's the grouping for the first two. Now let's do the second pair, 4x and 4. They have 4 in common, so let's take 4 out. It's going to be 4x divided by 4 is just x. 4 divided by 4 is just 1. Equals 0. In order to finalize our factoring, we just combine these two and the statements that came before the parentheses. So when we factor this, the final answer we get is 3x plus 4, 3x coming from this and 4 coming from here, and x plus 1, which is here in the parentheses for both. Now let's get rid of all of this and rewrite that. It was 3x plus 4 and x plus 1. And they were equal to 0. Now, two things are being multiplied, and the result is 0. When we multiply anything by 0, we get 0. For example, 1 times 0 is going to give us 0. So we can say that one of these two needs to equal 0. Either 3x plus 4 or x plus 1 has to equal 0. So when you multiply it by the other parentheses, you get 0. So what we do is we separate these two. We separate 3x plus 4. I'm going to write that a little bit more clearly. And x plus 1. And we know that one of these two needs to equal 0. So let's put both equal to 0 to find when they're equal to 0 and what x is. All right, then we solve normally. Minus 4 on both sides. We're left with 3x. 4's cancel out. 0 minus 4 is 4. Divide both sides by 3. X is equal to negative 4 over 3. Now let's do this one. This is simpler. Minus 1 on both sides. It's going to be minus. 1's cancel out. X is equal to negative 1. So when x is equal to negative 1, this is 0. And this number multiplied by 0 is going to give us 0. When x is negative 4 over 3, this is going to equal to 0. And whatever this number is, when you multiply it by that, it's going to give us 0. So in this case, x is equal to two numbers. X can be equal to negative 1 or negative 4 over 3. And in both cases, the answer will be 0. Now let's test that to check our answer. Let's say x is negative 1 and negative 1. Negative 1 squared is going to give us 1 because negative number times negative number is positive. And 1 times 1 is going to be 1. 3 times 1 is going to give us 3. 7 times negative 1 is going to give us negative 7. 3 and negative 7 is going to give us negative 4, which is equal to negative 4. So our answer is correct. And you can check the other one with this method also. Now let's move on to quadratic formula. This is the formula we have. Sometimes we get something that we can't easily factor. For example, 7x squared plus 16x minus 109. You can't easily factor this. So what we do is we use the quadratic formula. If you remembered from the previous class, the form of these quadratic equations were ax squared plus bx plus c. And using those letters, we can get this formula by plugging those numbers in. For example, if our equation was 3x squared plus 4x plus 5 equals 0, and we want to solve for x, instead of trying to factor this, we can just plug 3 for a, because 3 is a, plug 4 in for b, and plug 5 in for c. And then we can just solve. Now let's do an example. Our quadratic formula was negative b plus minus square root of b squared minus 4ac divided by 2a. And you have to memorize this formula if you get questions that ask for solving using the quadratic formula. And this is going to equal to x. What plus minus means in this case is the solution can be both written as plus square root of all of that and negative b minus. So this is basically combining these two forms of the same thing. Now let's look at our question. We can do this two ways. We can first factor it. Let's try to factor it. The multiples of 4 are 1 and 4, 2 and 2. Also negative 2 and 2, negative 2, and negative 1 and negative 4. Now they need to add up to 2. Negative 2 plus negative 2 is going to give us negative 4. Negative 4, negative 1 is going to give us negative 5. 4 plus 1 is going to give us 5, and 2 plus 2 is going to give us 4. So we can't factor this using the way we learned in the previous class. So we're going to find x by using the quadratic formula. Now, a is the one before x squared. In this case, it's 1, because there's nothing there. B is 2, and c is 4. So, negative b is 2, plus minus square root of b squared is 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 4, divided by 2a. 2 times 1 is going to give us 2. 4 times 1 is 4. 4 times 4 is 16. So we can rewrite this as negative 2 plus minus negative 16. 4 minus 16 is going to give us negative 14 over 6. Now, as you can see, in this case, we have a negative inside of the radical. And because we have a negative inside the radical, we can't take it out. And this basically means there is not going to be a solution. Because if you learned in your classes at the beginning of the year, there can't be a negative inside of the radical. So, what can this look like? If we imagine a grid, an xy coordinate, this graph, if we were to graph this, saying y is here, this would probably look like something like this. And that would mean that it doesn't touch the x-axis. So there isn't an x-axis where y is 0. So that means there's no solution, and you can just write no solution or draw the symbol. And that's going to be when you have a negative inside the radical. You can remember it like that. Let's do another example. We're first going to move the 20 to this side. That's going to give us x squared minus 9x minus 20 equal to 0. And then let's see if we can factor this. The multiples of negative 20 are negative 1 times 20, 1 times negative 20, negative 2 times 10, 2 times negative 10, negative 4 times 5, and negative 5 times 4. Now, let's add them up to see if any of them is going to equal to negative 9. 20 minus 1 is 19. Negative 20 plus 1 is negative 19. 10 minus 2 is 8. Negative 10 plus 2 is negative 8. Negative 4 plus 5 is 1. And negative 5 plus 4 is negative 1. So none of them are equal to 9. That means we have to use the quadratic formula, which was negative b plus minus square root of b squared minus 4ac divided by 2a. All right. A is 1, B is 9, and C is 20. And when we rewrote that, C is negative 20. Let's write the letters here. Negative B is going to be negative 9, which is positive. 2 negatives make a positive. Plus minus square root of b squared. Negative 9 times negative 9 is going to give us 81. Minus 4ac. 4a is 1, c is negative 20. can write it in the parentheses, divided by 2a, which is going to be 2. All right, 4 times 1 is going to give us 4. Negative 4 times negative 20 is going to give us plus 80. Now 81 plus 80 is going to be 161 inside of the square roots. So now we can rewrite this as 9 plus minus square root of 161 divided by 2. And if you don't have a calculator and cannot solve it, this would be your answer. And if you do have a calculator, you can just separate this into 2. 9 plus 161 divided by 2, and 9 minus square root of 161 divided by 2. And you can put that in your calculator and solve for the answer. But if you don't have a calculator, this can be your answer. And what this is going to mean that if you take a grid and put our line in, put our equation in, our x is going to be here and here, and this number, this x, is equal to these two. Of course, the negative one being the negative one and the positive one being the positive one. Now, the graphing is going to make more sense now that we are going to graph these quadratic functions and see for ourselves where x and y is. All right, this is the simplest form it can be in. This is a quadratic formula, and this is going to be known as the parent function. So y equals x squared is going to be the parent function of our quadratic equations. Now, how do we graph this? The first way we can graph it is to use a table. X, y. When we were graphing linear equations, this is also what we used before we learned the rules. Let's start from -3, -2, -1, 0, 1, 2, and 3. At -3, when we plug -3 in for x, we're going to get 9, because -3 times -3 is going to give us 9. When we plug -2 in for x, we're going to get -2 times -2, which is 4. When we plug -1 in, it's going to be 1. When we plug 0 in, it's going to be 0. When we plug 1 in, it's going to be 1 squared, which is 1, 2 squared, which is 4, and 3 squared, which is 9. Now let's graph these. -3, 9 is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. -2, 4 is 1, 2, 1, 2, 3, 4, right here. -1, 1 is -1, 1, right here. 0, 0 is here. 1, 1 is going to be here. 2, 4 is 1, 2, 3, 4. 3, 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we connect the dots, this is going to be our graph. And there are a few things I want to point out about this map. First of all, we call the shape of this, the U shape, a parabola. That's the shape of our graph when we're graphing a quadratic function. The second thing I want to point out is, as you can see, if you draw a straight line from the middle, you can see that they're mirror images of each other. This and this look like they're reflected along the y-axis. They're mirror images, and this is going to be important when we get into what we're going to cover next. The axis of symmetry. Now, the axis of symmetry is where the line mirrored itself. For example, in this case, when it's completely in the middle of the y-axis, the axis of symmetry is the y-axis. But when we have a graph, for example, like this, the axis of symmetry is going to be here. How do we find the axis of symmetry? Now, axis of symmetry is going to be a vertical line, which means we can write its equation as x equals a number. Because when we're graphing x equals a number, if it's x equals 2, for example, 1, 2, our line would be like this. So that's why our axis of symmetry is going to be x equals something. This is going to be our equation to find the axis of symmetry. And that's a typo. Let's rewrite this without the typo. It's going to be negative b over 2a. And that means we're still using the form ax squared plus bx plus c. And to find the axis of symmetry, the x equals a number. That's going to be our vertical line. That is going to divide the parabola. We use the negative b divided by 2a formula. Now we also have what's called a vertex. Vertex is going to be the point that is on this side. If it's a downward facing parabola, it's going to be right here. And that vertex is going to touch the axis of symmetry. So you can say the vertex is where the axis of symmetry intersects with the parabola. And how do we find that point? We found our x with this formula. X equals negative b over 2a. In order to find the y value of that x, which is going to be the vertex, we can just plug this x in back to the original equation that we're going to be given for the parabola, and we can find out y that way. Now let's see if it makes more sense when we start doing examples. X squared plus 3x plus 2. The first way we can do this is we can do a table. But the problem with these numbers, also when you start to get more complex parabolas, the problem is you are not going to know where to start. Should I start with 0? Should I start with this number? In order to do that, let's just find the axis of symmetry first. Alright, the axis of symmetry formula was negative b over 2a. A in this case is 1, b in this case is 3. So our formula is negative 3 divided by 2 times 1, which is 2. Negative 3 over 2 is going to be our axis of symmetry. Now let's find where that is. Negative 3 over 2 is going to be about negative 1.5, which is about here. We can draw our axis of symmetry. Now you usually draw this with dotted lines. Let's just do it a straight line to make it simpler. And then let's find our vertex. This is going to be our x value. So we're going to plug this back into the equation. X is going to be negative 3 over 2. And then there's the squared plus 3 times negative 3 over 2 plus 2. And that's going to equal to our y value. Negative 3 over 2 squared is going to be negative 3 over 2 times negative 3 over 2, which is negative 3 times negative 3 is 9. 2 times 2 is 4. So 9 over 4 plus 3 times negative 3 over 2 is going to be minus 9 over 2. And we can rewrite this by getting rid of the plus and replacing the minus next to 9 plus 2. And when we solve this, we can multiply this by 2, both the top and the bottom, and do 9 minus 18, which is going to be negative 9 over 4 plus 2. 2 is the same thing as 8 over 4. Negative 9 plus 8 of negative 9 over 4 plus 8 over 4 is going to give us negative 1 over 4. That's going to be about here, when this is our y value and this is our x value. So our vertex is about here. What we can do after that is we can, now that we know where our axis of symmetry is, we can plug in points around here and then just mirror that image on this side. Now that we found our axis of symmetry was here, and our vertex, which was around here, we can get to graphing. Let's plug the numbers over here. Let's start with 0. When we plug 0 in, it's going to give us 0 squared plus 3 times 0 plus 2. It's going to be 0, it's going to be 0, it's going to be 2. 0 plus 0 plus 2 is going to be 2. So at 0, it is 2. And after that, we can just mirror that image on the other side. It's going to be here. Now let's plug 2 in. When we plug 2 in, it's going to be 2 squared plus 3 times 2 plus 2. 2 squared is 4. 3 times 2 is going to be 6. And then there's 2. That's going to equal to 12. So at 2, it's going to be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is going to be about here. And then we can just mirror that image on the other side. There are 1, 2, 3.5 units between the axis of symmetry and the points, so we go half, 1, 2, 3. And that's where our mirrored point is. And then after you get all of these points, 5 points is enough, you can draw your line in like this. And that's your parabola. That's going to make defining the axis of symmetry, and then the vertex is going to make graphing parabolas easier. Now, if you can remember back in the linear equations video, we covered different forms of the same thing. And one was called the slope-intercept formula, and that's what we use to graph, to make it easier to graph. Now, in this case, in the quadratic equations, there's something called the vertex form, and that's if you are given the vertex form, it's going to be easier to graph than if you are given this form. Now, let's look at the form. This is how the vertex form is represented. As you can see, we still have our a, x, and y, but we have an h and a k. Now this h and k are going to be the intercepts of our vertex. Our vertex is represented by h minus k. For example, if we have a graph like this and our x and our vertex is here, it's like 2, negative 2, let's say. That's what that is. 1, 2, 1, 2. Then if our vertex is here, 2, negative 2, our h is going to be 2, and our k is going to be negative 2. And then you can just plug those points into the vertex form to get the equation for your specific graph. Now, how do we go back and forth between the vertex form and the form we have been practicing with? Now we have a form here like that, the form we've been practicing with, and let's turn that into the vertex form. First, we can find the vertex. Vertex is going to be negative b to a. Our b in this case is 3, so negative 3. And our a is 1, 2. 2 times 1 is 2. So our vertex is x coordinate of our vertex is negative 3 over 2. And then we can plug that back into the equation to find our y. And that's going to be 9 over 4, as we did in the previous question, minus 9 over 2 plus 2. And in the previous question, we solved that to be negative 1 over 4. And that's our y value. So our vertex is at negative 3 over 2, which is the x, and negative 1 over 4, the y. That means our h is negative 3 over 2, and our k is negative 1 over 4. So we can just write this formula. Y is equal to a x. Our h is negative 3 over 2. There's a minus sign in front of it, so 2 minuses, minus and minus, is going to give us a positive 3 over 2 squared plus our k, which in this case is negative 1 over 4. So we get rid of this plus, make it a minus 1 over 4. Now we still have our a left, right here. And the way we find this a is plug the numbers in. We know that from this question, when we plug negative 1 over 4 in for y or plug negative 3 over 2 in for x, we're going to get the other number. So we can do the same thing with this question and see if we get the answer. Let's get rid of all of that. Let's rewrite the equation again to make this easier. Now let's rewrite what we found. We found that the vertex was negative 3 over 2 and negative 1 over 4. And the equation we got was y equals a x plus 3 over 2 squared minus 1 over 4. And we're trying to find a. Now there are two ways you would think there are two ways we can do this. You would think that maybe we can put the vertex in, negative 3 over 2 and negative 1 over 4, plug those in for x and y, and solve for a. Now, we can't do this, and this doesn't work because when you plug these numbers in, we will end with 0 equals 0, and that wouldn't give us an answer. We're looking for a equals something, so we can't plug the vertex in. What we can plug is other numbers, other sets we can get from our original equation. In order to do that, just plug any number in for y or x. To keep it simple, let's plug 0 in for x. When x is 0, x squared plus 3 times 0, that's also going to be 0, 0 plus 2. It's going to give us 2 as y. Now let's plug 0 and 2 into our vertex form equation to solve for a. Y is going to be 2 equals a, open parentheses, 0 plus 3 over 2 is just going to be 3 over 2, all squared, minus 1 over 4. 3 over 2 squared is 9 over 4. It's being multiplied by a and subtracted 1 over 4. This equals to 2. So we're just bringing 2 down. Now, we can move negative 1 over 4 to the other side. In order to do that, we just do plus 1 over 4 on both sides. 2 plus 1 over 4 is just going to be 2.25. If you don't want to go into decimals, you can just say 2 is the same thing as 8 over 4. So 8 over 4 plus 1 over 4 is going to give us 9 over 4 equals a times 9 over 4 and 1 over 4 and negative 1 over 4 cancel out. In order to finish this off, you just, because these are being multiplied, divide both sides by 1 over 4. 9 over 4, 9 over 4. 9 over 4 divided by 9 over 4 is just going to give us 1. And on this side, 9 over 4's cancel out, leaving us with a. So a is equal to. So recapping everything we found so far, we found that the vertex is negative 3 over 2 and negative 1 over 4. And we found that a is equal to 1. Now that means h is negative 3 over 2 and k is negative 1 over 4. So let's combine all of this and write our answer. So y equals, now 1 times any number still gives you that same number, so it doesn't have an effect. So we can just skip that and write in the parentheses straight away. X, negative, negative makes a positive, 3 over 2 squared, negative 1 over 4. And that is the vertex form of this equation. Now, why do we find the vertex form? Why do we have something like this? Well, the reason we have this is because it makes predicting where our graph is going to be easier. Our A tells us whether our graph is going to look up or down, or whether it's going to be wide or narrow. Our H tells us if our graph is going to be left or right in terms of the parent function. And our K tells us whether our graph is going to be up or down. Now, what do I mean by that? For example, let's say we have y equals negative x minus h. Well, let's give everything a letter, a number. X minus 3 plus 1. Now, when a is negative, when a is less than 0, our graph is going to be looking down. When a is greater than 0, our graph is going to be looking up. So in this case, we know our graph is going to be downwards. And in h, if h is greater than 0, our graph is going to move right. If h is less than 0, our graph is going to move left. In this case, we have negative 3, but we know that our equation has negative h in it. So this is technically negative, positive 3. When we separate the negative that is in the equation, we find that our h is actually positive 3. So in this case, we know our graph is going to be moving this way. And lastly, we have plus 1. When k is greater than 0, our graph is going to move up. When k is less than 0, our graph is going to be moving down. So our graph is downward facing. Our graph is to the right of the original, and our graph is going to be 1 unit up. So let's go to this parent function to find where exactly that is. Because our graph is moving 3 units to the right, we first find that 1, 2, 3. And our graph is moving 1 unit up, so our new vertex is going to be here. And our graph is going to be downward facing. And because this is just 1 and there is no number in between, we know that the narrowness or the wideness of the graph is going to be same as the parent function. And as you can see, when you look at the slope of the parent function, you see that it's first 1, like that, and then it goes up 3, 1, 1, 2, 3, it's about here, and our new graph is going to be like this. So that's how you can use the vertex form and your knowledge of the parent function to predict and graph where a vertex form graph is. All right, that concludes today's lesson. In the next lesson, we're going to talk about combining exponents. This is something we already talked about in the previous lessons, but I want to go more in depth about it and talk about product rule, quotient rule, all of that. Next, we're going to graph exponential equations. And lastly, we're going to do word problems. And these word problems are going to be also reviews of everything we talked in the previous classes. We're going to look at linear equations, system of equations, pricing, all of that, and what we covered in this class also. Thanks for watching. I'll see you guys in the next class.